Welcome students. Today is the 36th class of digital land surveying and processing. In this class I am going to talk on how to establish the control point. Actually, for digital land surveying and mapping, after the specification for land surveying has been decided, the first thing we need to do in the field is to establish the control point. And in digital land surveying and mapping, we do establish the control points using a technology called GPS. So, GPS receivers are used to establish the control point. Now, the establishing the control point, as I have already discussed in the overview, that we need to go for planning of establishment of control point. That means what are the spaces where we want to consider the control points in our study area or in our project area. So, through reconnaissance we do decide about the location of the stations, and then after deciding the location we should establish. Now, the most important point in locating the station is that the station should be free from electrical interference, like it should not be near the transformers or high tension lines, or it should be away from some reflecting surfaces like water bodies reflects, or there may be some other reflecting elements around which may reflect the electromagnetic energy. So, while selecting the station point, these points has to be very much careful. Then the station point should be on a stable ground, and we should ensure that the location of the station points should be constant or stable all throughout the project time, and if possible maybe in years to come. Now, with these station points, then we should go for survey design. So, survey design is another important issue. So, after the selection of station points, another important point for our establishment of control point using GPS receiver is to design the survey. Now, survey design actually basically consists of two parts. One is that how to locate the station points with reference to other station points, and what will be the nature of observation scheme. Generally, we will have less number of receiver than the station number, then what should be the sequence of placing the receiver, that is called observation scheme. Now, first the network may be radial network as it is shown in this figure. That means we will be placing the main receiver or reference receiver at this location O, and then if we have to observe 5 stations, suppose we have only 2 receiver, then we will place one of the receiver at the centralized location and the other receiver may be keeping at 1 for some time, then 2, then 3, then 4, then 5, like that. So, the observation will be having only some radial along some radial lines with reference to O. So, these type of observations generally we take for area which is small, and we do not need to go for much of network adjustment. Another type of network which generally we do prefer to have in any survey work is to closed network, and for having the closed network we must have at least 3 receivers, and depending upon the area to be surveyed, these station points has to be designed, and most preferably at least 1 or 2 should be predetermined, pre-observed stations whose location and position as well as height is known. That will be useful for taking the network test, accuracy test. So, we have to keep it in mind that while we go for some closed network of GPS stations, then few of these stations should be already observed or available stations. Now sometimes for any project work also single, we may also go for a single station like the previous one. Suppose we have the one of this which is, then in that case what we do, we do select stations all over the world, IGS station all over the world and well spread about this point. These are the IGS stations, IGS stations, and what we generally consider to have the data observed at this station at the same instant of time along the same duration what we have observed for O, and then subsequently we may process that data. Sometimes we also consider this type of network where the observed station will be in within our project. This is our project area, and the station that will be used for making during processing to find out the location of this is IGS station. So there are different ways how it can be done, and this type of virtual reference station, VRS, virtual reference station. So sometimes we also consider this. I will demonstrate on this point how to do this thing. And so after we have decided the network of stations, then we should select how we should set up our receivers. What is the sequence of different receiver has to be placed, like in this one of the scheme here I have shown that there are A, B, C, D, E, F, that means there are 6 stations we have and we have 4 receivers. So how we should go for taking the observation, and here you can see that we are taking the observation at different sessions. That means sessions means some duration along which we will take the observation. Now in session 1 we are taking A, we are placing the receiver R1 at station A and receiver R2 in station E and R3 in station C and D. So A, E, C, D. So in this way we are observing. So you can see if I take the observation simultaneously on all these stations, then we will be having these baselines, these baselines, this baseline and this baseline, a closed network of quadrilateral. So also that can be consist of 2 triangles like this, again these 3 triangles, then we can go for a lot of network adjustment loop closure analysis what we have studied in our network adjustment class. So we have to look into that thing. Next session A, B, C, F. So A, B, C, F. So this big rectangle we are observing. So A, B, this is another triangle we can get, A, F, C we can get, F, B, C we can get, F, A, B we can get. So 4 triangles and then big rectangles we can get as a closed figure. So we will be able to do a lot of network adjustment or analysis, and we can find out many of the errors associated with the observation or the computation or the any other lack in quality on the observation. We can also remove some of the, so a lot of redundancy in data will be available, that will make our work easier and better. So like that we will take different combinations of stations observation, and that comes under the observation scheme. Our main objective of observation scheme is to have all the baselines to be observed, and there is a simultaneous observation between different baselines, and a lot of closed network should be available simultaneously, and there will be redundancy in observation, and those will give our work observation will be stronger. So, these are the things we should keep it in mind while taking the observation. Then another thing, whenever we will, before we really take the observation, we should also see what is the status of the satellite during that time. How many satellites will be visible to that particular station, and what will be the duration of visible, what will be the quality of the observations. Now, quality of the observations will be noted, will be understood through the Dopf values. Already I had discussed in some other class. So, and for any particular station, for any particular day, during all throughout the day, what will be the different types of Dopf value that we can get. You can see here the different lines are there, and this is the geometrical Dopf value, that means G Dopf. This is the line provides us the Dopf values, and we can see here that this Dopf value is maximum at this point, which is about 2.5 or more 2.6. Now, we know that Dopf value should be least. The lesser the Dopf value, better it is. So, in this case we can see that this region will provide us the best type of observation values. If we consider this case, here you can see the Dopf value is least from at this point, that means around 1230, and the Dopf value is decreasing here, is slightly increasing. So, if we have to select a observation window of 1 hour, so I can see that from this point to this point will be a good time, that is the least Dopf value. So, in that way, if we have this Dopf plot for a particular place at and over the period of time, by looking at this we can identify that at which time or at which time of the day we should go for observation. And also if we want to take our observation from 12 hour to 18 hours, then our Dopf value will be within 2.8. So, I think as we know that 2.8 is also a good number. So, we can very well take our observation. So, Dopf value is an indicator of the quality of the data, and lower the Dopf value, better it is. So, this is a very important information for choosing the observation window. Now, also we can find out from some planning software what is the number of satellites available, which are the satellites available. So, all these information will provide us to select the observation window as well as observation session. So, in that way we do select, and then once the observation window and observation session has been selected and the observation scheme has been designed, then we do go for observation, and then after taking the observation we should also check the quality of the data what we have acquired, and once we are satisfied with the quality of the data, then we have to download the data and import the data to the processing software. Now, processing has to be done in 2 steps, or I can say pre-processing and processing. Now, as we know that the GPS data contains a lot of errors, so we must make use of different pre-processing operation to minimize the error. First, we should go for triple difference observables to find out the cycle slip detection and repair. Then we should remove those things, and then we should also go for double difference observable. So, all this processing we have to do, and then in that way we can improve the quality of the data. Also, before processing, further processing, we should also again test about the quality of the data, and already I had discussed about how to test the quality of different types of data. Now, once we are happy or satisfied with the quality of the data, we should walk further with the double difference observable of the base station only for this type of processing. So, this is the base station, and now we should see what is the duration, on which day, during which time we have the base station data, and during the same time we should search around all over the world about the IGS stations during the same time, same day. What are the IGS stations where the data has been observed having the epoch same or less than what we have taken. That means, if we have taken observation at 15 second or 30 second epoch, the epoch of observation from other station IGS station should be either, if it is 30 second, then it should be less than 30 second. So like that, we first we have to identify the IGS station around the world where the same day and during same duration or more than that duration, but in the around that duration data has been taken, and those data has to be downloaded in the software and along with the data. Now in case of controls point establishment, we want to have the position very precise. So to have the precise information about the control point, we need to go for precise ephemerides instead of broadcast ephemerides. So also we need to download the precise ephemerides from the internet site. So all the precise ephemerides for all these stations along with this base station has to be available in the same file and within the software. Now it will be preferable to make use of scientific software for our establishment of control point. However, if scientific softwares are not available, we can go for commercial software, but that will provide us less accurate GPS position. Now once this data is available, then we should go for processing. Now processing of GPS is done through network adjustment. So first what we have to do, we have to go for baseline processing. Baseline processing, that means first we should go for baseline between the IGS station and our reference station, then this baseline like this, then we can put together all these baseline, and we also need to know the IGS station coordinates. So IGS station coordinates are available also in internet. So from internet we need to know IGS station coordinates, IGS station data, then precise ephemerides of IGS station as well as our reference station. So all these things we can get from internet. So now this IGS station, fixing this IGS station coordinate, we can find out the coordinate of this reference station. After doing, the software provides us the error ellipse around our station. Error ellipse represents the amount of error associated with the any station, and we should see whether our error ellipse satisfy the requirement of our specification. So that is the way how we go for our establishment of control point. Now I will demonstrate you how we really do this establishment of control point. We will make use of some commercial software called Pathfinder, through which I will like to demonstrate the various steps that we can do to establish the control point of, or to establish or to find out the location of the baseline reference station, and from the location of the reference station also we can do the adjustment for our other control points of our project area. So to start with, first we have to create a new project. Suppose project 4 is the object which we will like to name as the, and to the modify default settings, let us take whatever default settings are there except miscellaneous. Under miscellaneous we take this VRS maximum range as 3000 kilometer. I have to import the data which we have collected in the field. So, and that data has already been transferred to this office computer from field computer, and that is kept in a folder, and from that folder I will import the data to this project work. So, that is the file which is our base data. Now, with this base data I am importing it, it is there. Now, we have to go for this VRS, and so if we click here, then all these station will be checked. So, and we are trying to download the data files of these stations, particularly in which stations the observations are available for 12th July, because 12th July is the day on which the data for this our base station has been collected during this time, start time and duration. So, now the software is checking whether these IGS stations also has the data for this date and during these hours. So, only those stations for which the data will be available, then only will be considered, that can be considered for our further processing. So, in order to know that, we need to carry on this process. So, now you can see here that for some stations files are not available. That means for this station AFKL data has not been collected during the observation period which we are looking for. For this station there is some error in downloading the data, but you can see here that some stations like HYDE, KIT3, POL2, the data is available for that period, and also it has been downloaded during our this processing. Similar to that, there are some stations for which there will be data available. So, among those stations we have to select which are the stations we will be looking for our data for the processing. Now, in doing that, actually we should first see that we should like to have the stations around our station in such a way, so that the stations provide us a good network, as we have discussed in the closed network. So, in this case I can see that the station here, this and this will be good. So, let me select those stations from here, then you will see the network. So, I will like to go for KIT3, then IISC, CUSV and another is NOVM. Now you can see that this will form a good network of triangle, and so I am selecting these 4 stations as our reference data to get the location of this station. Okay. Now we have to click. Now we have to import the data that has been downloaded and that is available in this office computer. So generally it is the name of the folder VRS extension. So now these are the data which we are looking for: IISc, CUSV and NOVM. These observation files we are in need to work, so we have to open. So we are importing this thing. Now this is the network of triangle. So now we have to select the, we can go to there, we can define the control points. Now we will like to take these 4 as our control point. Now for these control points, actually this latitude, longitude and height whichever is available here, that is actually from the data. Now before we go for any further processing, actually we should first download the actual position of these stations which are available in the internet site, and that has to be, those data has to replace this data. Now for CUSB we have the actual longitude, then latitude 13.7359, then ellipsoidal height 76.06, 76.06. For KIT3 it is 66.88, latitude 39.14 and height 643. For NOVM it is 82.9095, then latitude 55.0305 and height 149.9800. And for IISc 77.5704, 13.0212 and height 816.6000. So with this, okay, this is the location of the control points as available from IGS site. Now we can process this now process all baseline. So that will, after processing the stations as baseline, we will get the location of the reference station, and for our further work we will be using that position of the reference station as our known point. Now of course in this processing you can see there are big ellipse circle which are the error circle, and actually we need to reduce this during our further processing so that these errors are not more. Now with this I got, let us see what is the output that we can get from land survey report. Okay. So this provides us the location of the base station as 77 degree, 54 minute as the east, and that latitude like this and ellipsoidal height this. So this is the data which we got as the location for our reference station. So for further processing we will be using this as our known position.